hence the Phoenix. And the reason I think this is really important is because the Linux community, for the last couple of years, have had all the fun. They've had all of the great automation, they've had all of the great tooling, and in the Windows, and when deploying Windows applications, especially legacy Windows and .NET applications, it's just a little bit more difficult. It's more time-consuming, it's more problematic to automate, and it's just more difficult. That is until Windows Server 2016 has come along, and they've added some new functionality, they've added container support, they've got Docker integration, and that's made everything a lot simpler and a lot easier to automate, even more traditional, older school Windows applications instead of your nice shiny .NET cores of the world. So my name is Ben Hall. I am one of the organizers of Docker London meetups. I'm also a Microsoft MVP in cloud and data center management. And more importantly, I'm the founder of Ocelot Uproar. We do a product called Katacoda alongside many other things like teaching people Docker and helping them integrate containers. But Katacoda is a free interactive learning platform for software developers. It gives you a step-by-step tutorial about how you can learn things like Kubernetes, Docker, and alongside that, an interactive browser-based environment so that you can play with everything and have everything set up without needing to download or install anything. So what I'm going to talk about today, well, I'm going to talk about how we can start automating deployment of applications on Windows Server 2016, what that entails and what's actually happening under the covers. So I'm going to first give you an introduction into containers and give you some context into what we're talking about. Then going to move on to how we deploy Windows applications and Windows and .NET applications inside of these containers. Discuss briefly the differences and why Windows and Linux and Docker is slightly different and what's happening under the covers. Something called HyperV Containers, and then look towards scaling and towards the future and how this all will actually work in reality and in production. So containers. What are containers? Well, if we think of the real world, and we think of how the real world operates in terms of containers, they're these huge, big, massive metal shipping containers. They're about this wide, they're about this high in terms of scaling, and they have certain key properties. Like, for example, they have doors in a certain location. They are obviously a certain size. They've got certain labels in certain places so that they can be scanned. And more importantly, they've got 4 hooks in each of the corners. It's these hooks that allow them to be connected and allow them to create this very strong, coherent unit that you can put on big, massive shipping containers and send all the way around the world without them falling in the sea most of the time. But what's on the inside of these doesn't really matter that much. And you don't really care, and it doesn't really matter from the shipping company's point of view. It could be cars, it could be T-shirts, it could be part-built products. What matters is that consistency from the outside. It's that consistency that they all look the same, they're all the same size, they can all be connected to in all of the same way. And it's this consistency which makes it scale and makes it work. And that's kind of what we're getting to within terms of software deployments and software containers. What's running on the inside of a container doesn't really matter that much. It could be a .NET Core application, it could be a VB6 application, it could be SQL Server. That doesn't matter. What's important is the consistency about how we start these processes, how we build these containers, and how they work at scale. And that's what we're aiming for, and that's what we're heading for. If you think about the 2 types of virtualization, containers take a type of virtualization. Traditionally, we're used to the HyperV, hypervisor-based virtualization. So your ESX, your Zen, your HyperV. And while this has been very successful, it also comes with a huge amount of overhead and kind of like a heaviness which comes along with it. And that's because in order to provide security and sandboxing and abstractions, your host operating system needs to have a hypervisor, which then boots another guest operating system. And so in order to be able to get your flexibility, you had to boot up this guest operating system, which depending on what you was running, if it's Windows, it could take 10 minutes to boot up, in order to start your application in the first place. And also, to keep your guest operating system happy, you had to pre-allocate 16 gigabytes of RAM, 40 gig of disk space, and it was just a huge amount of overhead, which slowed everything down and made it difficult to scale, and made it difficult to be more dynamic. And hence, we ended up with long-running virtual machines, which lasted forever because they were too difficult to move around and move between different services and kind of scaled more dynamically. And so this is where the container mindset has come in. It's tried to make everything a lot more simple, a lot more lightweight, and a lot more flexible in terms of scaling and migrating workloads. And so instead of having a hypervisor, i.e. Hyper-V, we've now got the Docker engine, or a container engine. And the container engine contains and offers kernel virtualization. So instead of virtualizing the entire guest operating system, we're virtualizing the kernel. And so this allows us to take advantage of the host operating system kernel, but still deliver sandboxing, still deliver security, still deliver restrictions that what we're used to from a security point of view with virtual machines. In terms of the container itself, it's got everything your application needs to start. So if you're deploying a .NET application, the container will contain the .NET framework, it will have all of your built binaries, it will have all of your application configuration. And everything in a container is separate from everything else. So while one container could be running Node.js, another could be running Node.js version 7, another could be running .NET. And they're all sandboxed, they're all isolated, they're all separate. But containers are not virtual machines. They have a key important difference, and that is the overhead, and that's the allocation. Because you don't have this guest operating system, which requires booting up, you don't have to wait 10 minutes for your process to start anymore. It starts instantly. Because of this, I like to think Docker is more like a process manager more than anything. Fundamentally, all you're doing is starting processes. You're just starting your .NET application. And Docker providing that security, that packaging, that consistency that we want from our viewpoint. And Docker is the tooling. Docker is the thing which had made all of this possible and made all of this ecosystem available to us. Containers have been around in many different forms for the last 20 years. They originated as a concept in FreeBSD, where the creator needed to be able to run FreeBSD alongside developing future versions of it. And he wanted to do that in a very streamlined, very fast, very appropriate way. And then they kind of iterated multiple times. They appeared as jails and zones in Solaris. And then Linux came along with LXC. And then Google enhanced that with C groups and namespaces to provide more security and more restrictions and more control over how these processes are running. And while it was all possible and it was all there in the Linux kernel, you kind of had to be really, really passionate in order to be able to take advantage of it. It was not the easiest thing in the world in order to be able to deal with on a daily basis. Thankfully, Docker has now made that simple. Docker provides a set of tooling and a set of APIs so that we can work with containers on a daily basis, and we can build our entire development lifecycle around them. But Docker is also realistic. While it's a huge company and they're doing many fantastic things, they can't solve every single problem. And so they've got the mindset of batteries included, but removable. Out the box, they want you to have a great experience. They want you to have all of the tooling and all of the functionality there to get you into production and help you solve real problems. But if you're talking to some like really expensive storage array or got some weird, interesting networking problems, they're realistic that maybe that's not the most appropriate problem for them to solve. Instead, they rely on the ecosystem, and the ecosystem which is building some amazing companies who solve the really interesting problems of dealing with networking at scale or dealing with the interesting storage devices from the EMCs of the world, for example. And Docker made it open, made it accessible, and made their entire platform pluggable so that these things can be easily swapped in and swapped out as you grow in terms of complexity within your system. And for me, in terms of what containers and Docker and what's important, there's three key concepts. Firstly, we have these Docker containers. And these are actually the running processes which are sandboxed and secure and have got all the isolations which we demand from our system. These running processes start life as a Docker image. And fundamentally, you can kind of think of this as a layered zip file. We'll get more into this in a moment, but this has got all of your configuration, it's got all of the files, it's got all of your dependencies. And instead of it just being one huge zip file with everything required, it's been broken down into layers. It's these layers that allow us to reuse and reutilize different files between different projects. And so we don't have to keep managing and installing the same .NET version for every single application we deploy. Instead, that we can repurpose the .NET installation. So we get more space saving, it's quicker to deploy, it's quicker to manage. And all of these images live inside the Docker registry. For those familiar with the Linux world, a public Docker registry is the DockerHub. It's where all of the images live. It's where we can go to find, discover, and download applications which have been pre-built, pre-configured. And we can also deploy and host our own Docker registry internally and on our private network. Many cloud providers, such as Azure, have this as a service. And this is where we keep our applications and keep the images which we're building. And this, so that's Docker. And in terms of Windows containers and the work which Microsoft are doing, Microsoft are working with Docker to make it part of the same application. It's not a fork, it's not a different distribution, it's part of the main Docker release. And we can see this by looking at the Docker source code, because everything is open source, which is amazing. And you can kind of see some interesting aspects, like we've now got Windows directory, and it's taking advantage of Golang, and so we can have targeted builds for Windows, for Linux, for OS X. And also we see some interesting things coming from Microsoft in terms of how they've changed and how they're dealing with the container ecosystem. And like we've got a Windows I/O library publicly available on GitHub written in Go, and we've got a Microsoft HCS shim, which is a host container service, and it's an abstraction over the API to allow that Docker and the Windows kernel to talk to each other. And so it's all open, it's all in the public, and so we can kind of start to see Microsoft's intention and workflow and their internal process in terms of how they're thinking about containers internally, which I think is really cool. So what is actually coming in Windows 2016, and what's actually coming along to make all of these containers possible and make life easier for ourselves? So there's 4 new key components which are coming: Windows Server Core and Windows Nano. These are operating systems designed to run inside containers and designed to give us the tooling which we need in order for our process to run, but also support all of the traditional APIs which they would expect. And then there's 2 new ways of running. There's Windows containers and there's Windows HyperV Containers. And I'll get into the differences in a moment. And just like our friends in the Linux world, the way Windows containers work and feel and operate are very, very similar, almost identical in many ways. So you've got your host operating system, Windows Server 2016. That could be running on bare metal, it could be running in Azure, it could be running wherever we desire. On top of that, we've got the Windows kernel. That's the thing which is now being virtualized and broken up and got all of the new hooks in there so that we can run these containerized processes. We've got the Docker engine, which is the build for Windows. So this is, again, got all the functionality which we'd expect from Docker. It's a complete supported release. And then on top of that, we can run our processes as individual containers, all separated or sandboxed, all isolated, without them interfering with each other. In terms of Windows Hyper-V containers, they offer an additional level of security, an additional level of protection. So instead of us sharing the same host kernel from our applications, Windows Hyper-V containers allow us to wrap that container inside a very small, very lightweight virtual machine. And this allows us to have a separate kernel, and this allows an additional layer of security if our particular deployment requirements desire it. And thinking about when you would use one of the other ones, obviously Windows containers have got everything which you need. They're secure, they're scalable, they're highly automated, they're all of the things which we kind of desire from a deployment technology. Windows Hyper-V containers are useful in 2, potentially 3 circumstances. One is you're a platform as a service, someone like Heroku or maybe Azure, and you're hosting third-party software, which may be not as trusted as it would be if it was running internally. So this may be maliciously trying to exploit it in some interesting and wonderful ways. The other side is multi-tenancy, where, again, you're running on you've got multiple vendors, multiple partners which you're hosting, and it could be very awkward if somehow they did manage to break out of a container and they managed to break into another competitor's container running on the same machine. And that could just be a little bit embarrassing for everyone involved. And so this is where Windows HyperV Containers come in. It's where you need that additional level of security, additional level of auditing, that additional support, just in case a zero-day attack did come out and a container breakout would be possible. But for most of the time and most applications, Windows Server containers will be perfect, and they'll get you to where we want to be. So now we've got Windows containers and Windows HyperV containers. They allow us to run processes, and they allow us to start our applications. So now we need something to actually run inside of our container. So the container's got everything which the application needs in order to be able to start. So it's got your application itself, it's got the .NET framework, it's got the JVM if you're running Java. But alongside that, it also needs an operating system, because it expects the operating system to be there. The only thing that Docker and kernel virtualization is offering and providing the container is the kernel. It doesn't interact with the host operating system and the files on the host operating system in any way. Instead, it's completely sandboxed, completely abstracted, completely secure. Because the worst thing is, you're running a container which accidentally deletes all of its files, which happens in an automated test build scenario sometimes, and then that destroys your host, which has happened many times when you're running automated scripts. If containers shared the host operating system in any way, that would kind of destroy your host, and that would then destroy other containers running, which wouldn't be ideal. In order to live that sandboxing and that isolation, the containers need to be able to have the operating system running inside of them, or a version of the operating system. And that version, to start with, is Windows Server Core. It's nearly Windows 32 compatible, which means it's got all of the legacy APIs, it's got everything which your application would expect, apart from a few interesting things like a fax server, which definitely doesn't need to be inside of a container, doesn't really need to be inside Windows full stop at the moment. But the idea being is it provides all the same behavior, it provides all the same tooling. It's designed for you to be able to pick up an existing application and drop it in a container and work. And that's the ambition of what we're driving for. And then we've got Windows Nano. Because, yes, where we need to be able to support more traditional applications and traditional APIs, not all applications need them, especially as we're looking forward towards .NET Core and moving towards a more cut-down, lightweight development process. We need an operating system to match that, and that's where Windows Nano comes in. Everything has been really stripped down. It's come down to like the core, the key components of what makes up Windows, i.e. networking, storage drivers, the .NET, the core CLR framework itself. And as a result, it's a 20th of the size, it's much more lightweight, it's much more easy to be deployed on. But as a result, it doesn't support every scenario, every application. And so, for me, there's two ways of thinking about it if you're familiar with Linux. Like, Windows Server Core isn't booted. Like, it's a traditional operating system which has been around for the last 10 years, and you'll get most applications deployed onto it without any modifications required. Where Windows Nano is like the Alpine Linux. It's like small, cut down, really shiny, really new, really fresh, but you may have to make some modifications to your application in order to be able to take advantage of it. And so this is where I see the two operating systems coming in and the two requirements, why they exist side by side. So how do you install these, and how do we get started, and how do we actually start playing with them? So if you're running Server 2016, you can add a new module, you can install the Docker package, restart your machine, and that's it. You have everything which you need in order to be able to start deploying Windows containers. If you're running on Azure, there's Windows Server 2016 with container support. This contains everything set up, everything which you require in order to be able to get started, playing around, deploying, and building Windows containers. And so once you've got that server in place, you've got Docker Client, which is your command line interface, and this can talk to Windows Server, or it can talk to Linux servers. And so you can work from that from your guest operating system, talking to Azure, talking to Linux, everything being this like really lovely cross-platform ecosystem from your single machine. And then obviously the Docker Client will talk to the Docker engine on one of those two. That will in turn talk to the kernel, and that will in turn know how to start processes as these containerized ecosystems. And alongside that, we've got the layered zip file, as I'm going to refer to it today, the Docker image. And so this will come from the registry, which has got the, all of the support and all of the images which we need. And we've got that as we extend and as we build our container image and add our own applications and add our own customizations to it, that gets added as an additional layer on top. And as such, eventually when that starts, from a container's point of view, it looks and feels like an entire Windows virtual machine, but in reality, it's running inside of a container. On a slightly separate but similar, completely unrelated note, in Windows 10, we've got the Windows Linux subsystem. The Windows Linux subsystem allows us to run Bash and allows us to run Linux processes on top of Windows. This is completely separate to the work that Windows are doing in terms of container support. But it's important to identify the differences and the reasons why. The Linux subsystem is taking Linux processes, emulating them, changing, re-implementing the system calls under the cover, and translating them to Windows system calls. And so there's this layer and abstraction in the middle. In terms of what container support are offering, containers are native. They allow you to run Windows applications natively on top of Windows with proper hooks in a kernel. But what that means is that we can't pick up an existing Docker Linux-based image and expect it to work on top of a Windows Server 2016 machine, because the Linux image will expect a Linux kernel to be there, and it will expect the Linux hooks in the kernel and all those kind of expected things. Just in the same way that we can't pick up a Windows Docker image and expect it to run on Linux, because we need a Windows kernel being there in the first place. And so that's where the virtualization and the kernel virtualization comes into play. But in the future, this is a really cool technology, and it will be interesting to see where Microsoft goes in terms of where that's heading. But it's important not to confuse the two. So I keep talking about these Docker images and these Windows Docker images, but what are they? Let's start building and let's start playing. So when you have everything set up, you've got your Azure image, or you've installed Windows Server 2016, everything's fresh and everything's clean and everything's working. So the first thing you can do is type in Docker images. And this will provide you with the two container-based operating systems, the Windows Server Core, which is that slightly larger installation, slightly large Docker image designed for most applications, and then Nano Server, which is a cut-down, lightweight version of it. And then you'll also see the particular version number as a tag. So this is the Windows version, this is the Windows build that we can use in order to track what's been updated, what particular version of security fixes we're at, etc. In order to take these images and turn them into a container, we use Docker Run. And this allows us to start processes using that image as our base, as our foundation, with everything set up and everything configured. So if we do Docker Run, IT kind of makes it interactive and attaches a terminal. That allows us to send inputs to it. Windows Server Core, which is our full operating system version, the traditional one. Let's say run a command prompt, and in the nice, lovely blue, we've got my PowerShell on my host, which launched the container. And in the black, we've got the lovely traditional Windows command prompt, which has got everything you would expect. This is running inside of a container. It's got a different host name to my host operating system. It's got similar looking files, i.e. inetpub, program files, users, Windows directory, but it's completely isolated and completely separate to the files which are on my host operating system. So if I decided to format the Windows container, that would be fine. Obviously, the container would be not very useful at the end of it, but it wouldn't have any devastating problems to the rest of my application, which within Katacoda, I'm fully familiar with how everyone tries to delete the container. If you look at what's running inside the container, there's something called SSMS, which kind of, if you are familiar with how Linux container works, in the Linux world, you say, what's running inside of my container? And generally you'll only have bash, and you'll have PS, which is listing all the things running. Windows, because of the historical nature of Windows, applications expect other things to be there to support the running of the application itself. And so you'll expect and see things like SVC hosts, for example. And because it's Windows, there'll be multiple different things of these working to support it and to make sure it's happy. And there'll always be things like trusted installer, like PowerShell, which is what we're running. But when you see it, these are all processes running inside of the container. Again, they're not shared, they're not interacting with other things happening on the system. They're just there in order to support what Windows needs in order to be able to run effectively. So we've got something running, we've got a command prompt, which is great, but not massively useful. So let's start building something. And let's be realistic. If you're the 90% of applications, I imagine, which will have taken advantage of Windows containers will be something which has been historically deployed onto a system and wants to be modernized but still needs to be maintained. And it still needs to be supported in some way. And the chances of rewriting that inside .NET Core is probably not going to happen this year. But you still want to be able to take advantage of the container support and all of the nice tooling that comes with being able to deploy more effectively. So I tried to find the oldest application I could, and I did. It was the Nerd Dinner 2.0 application, lovely built and released in May 2010, which I kind of thought that's not that long ago, and then was like, actually, that is quite a good long time ago. We've got the author still actually works at Microsoft on the team, which I think is even more impressive. Not due to his coding habits at all, obviously. And obviously, this is an application, and it's been like 6 years since I last looked at this application. So I can't remember how any of it works at all, let alone how to get it running. But thankfully, John kind of thought about this. It's got all of the binaries which had been built as part of the package, and there's no package managers involved. So everything the application needs is in that zip file. So this made my life a lot simpler to start with. But fundamentally, I don't know how it works. So let's turn this into a Windows container, and let's see if we can go back to those glorious days and have a nerd dinner again. So the first thing which we need is obviously Windows Server 2016. So I'm going to use Azure because it's not that expensive, and it's a lot quicker than getting everything set up on my MacBook Air, especially for prototyping and seeing how everything works. And so once it gets set up, you obviously have this great configured server. Because I'm running everything, or I will be running everything as containers, I don't need to do this. The whole benefit, what we find with containers, is my host operating system doesn't need to do anything anymore. Everything which has got some complexity, some configuration required, is done inside of the container. So all of my host does is really run Docker and run containers, and that's it. And because I've picked that image, that data center image with container support already, everything is now done. The only thing which I did add was Chocolatey. Now, if you're not familiar with Chocolatey, this was like a revelation to me when I came across it. Because instead of having to load up IE and get around like security barriers to downloading an executable, you don't need to do that anymore, which I only just realized this, hence why I'm quite excited still about it. If everyone else knew about it, then okay, fair enough. But you can use things like install Git from the command line again, and you can install Docker from the command line and the Docker Client, and it's awesome, and it was great. So I use this to install Atom. So I could at least have an IDE on my box to actually have something working. And it was basically Toco install Atom, and I had everything set up working in a lovely, nice way. So now we've got it, so now let's start working with Docker. So we've got Docker version, so the Windows build of our container engine, which is running. You do Docker PS, that lists all of the running processes, all of the running containers. At the moment, nothing is happening. But we list Docker images, and we'll see these nice Windows Server Core latest and Windows Nano latest. One important thing to remember here is that latest isn't actually latest. Latest I consider a little bit of an anti-pattern, because latest is a moving target. It's a tag which points to the latest release at a certain point of time. But if you're building on latest, that means that it also changes as other things, other packages iterate. And so what could be Windows 10 one day could be Windows 11 the next, if Windows 11 ever comes out. I don't know how it works anymore, but you get the idea. And so you've got this constant moving target, and so you could accidentally introduce breaking changes because the latest tag has been moved upstream. So instead, if you look on DockerHub and you look at all the images, there's actually the proper build numbers and the proper versioning and proper internationalization versions of each of the containers. And so it's much more accurate to pull down the latest build when you get started, which was released 8 days ago, because this way you can be confident it's got all the latest security patches and all the latest updates. If you just start using the latest image which comes with it, you may be slightly behind the curve, and you may be slightly building upon an older version. So to download the latest version, you do Docker pull Windows Server Core. You give the build number as a tag using that colon syntax, and that will pull down the latest versions. Now notice that while my Windows Server Core base image is 9 gigabytes, which yes, it's quite big, but at the same time it's also like the whole Windows ecosystem, or the whole Windows installation. The things which will download is only the additional layers which you don't already have. So it will only download the security patches and the security fixes which have been added upon that base build. And so in this case, we're only downloading 900 meg, which is still not like insignificant, but it's much better than downloading 10 gigabytes every single time. Instead, you're only downloading the changes and that delta from what happened beforehand. So now we need to build our image, and this is where a Docker file comes in. A Docker file is a list of instructions which define how your application can be built and deployed and running in an automated way. And these instructions just define steps that the process should run to in order to take your nice, clean, fresh Windows Server container image and then have your application on top. So this is what we need in order to be able to deploy Nerd Dinner as a Windows container. So to start with, we need to have IIS. That seemed like a sensible point, where it's a full-blown .NET MVC application, MVC 2, I believe, at that time. I think it was MVC 2. So let's start. So we first define our base image. So this defines all of the dependencies which our application needs in order to be able to start. You're basically picking, am I expecting Windows Server Core or Windows Nano? That's kind of like the two biggest changes, two biggest decisions at this point in time. And then we can run additional instructions in order to be able to add and extend this base image. In this case, I'm running PowerShell. I'm telling it to install a Windows feature web server, which is IIS. So we've got this Docker file. We can do Docker build, give it a nice friendly name as IIS, and tell it to build and produce our Docker image. We're doing this so that other applications which come along can reuse this IIS installation, and so we don't have to keep installing Windows Server every single time we want to deploy. It's kind of been cached for future versions. But thankfully, Microsoft have also kind of thought about this being a common scenario and a common use case. And so they've already done this for us. And so they've already gone ahead and they've built that Docker image so that we don't have to worry about how to take and how to have an image running IIS. So on the hub, DockerHub, which is the Docker registry, which is where all of the Docker images live, you go to the Microsoft page or the Microsoft profile. You've got the IIS page, and it tells you the instructions and it tells you the commands to start. and it tells you all its different versions. So there's a version for Nano Server, and there's a version for Windows Server Core, depending on what you're targeting at the time. So instead of building our image, we can target that image instead. And so now, from our application viewpoint, it's basically saying, I need IIS installed in order for me to be able to deploy this application successfully. So just make sure that IIS is there, running Windows Server Core configured, and make sure it's at the latest version build, or make sure it's against this build version, i.e. 14.3.93. And then, just to make sure that everything's happy, define the shell, i.e. what to use when you're running future commands at PowerShell. This allows us to take advantage of all of the PowerShell functionality and the PowerShell scripting approach which we need. So now we've got IIS installed, we need to start customizing this base image depending on what my application requires, or in this case, John's application. So the first thing which we will need is .NET Framework and ASP.NET 4.5. So just like you have with IIS, the first thing which you would do using the traditional management console is go through, tick the boxes in order to be able to have that functionally built in. And so now we're automating it, everything is scriptable, everything is repeatable, so we're using the Windows install features in order to be able to have that. And so when we do a build, what we'll do now, or what Docker will do now, is like, okay, I've got IIS, and at the end of this, it'll say, like, right, there's IIS with Windows, with ASP.NET configured and installed and capable of running applications, which is cool. So now the next stage is, we've got IIS set up, we need to configure it. And so we do this with this, using the PowerShell commandlets. Wow, I used the right word with PowerShell for once. Excellent. So the first thing to do is remove the default website, because it's just clutter and we just don't need it hanging around. Second thing is we need a directory where our application source code will live. So we use make directory, nerd dinner. And then we create a new website, new iOS website, give it a nice friendly name, say that it will be running on port 80, the physical path will be nerd dinner, and the application pool will be .NET 4.5. And so this should, if you've done any iOS automation previously with Windows 2013 or something, this should start feeling familiar. It's kind of all we're doing is customizing exactly the same way that we would with our traditional approach. We've now just defined it as a Docker file. And then finally, to give some syntax and some heads up about what ports are exposed and what ports processes are running, we say expose 80. And then finally, we copy the directory from our source code and copy from our host. We copy the source code from our host, which is in our directory called nerddinner, into our container and say, put it at c:nerddinner. And so this is our instructions about how we need to deploy our application and what needs to happen in order to be able to get it from a clean, blank IIS installation up to have everything running and everything configured and all the source code in all of the right places. So now we've got this, we do use the docker build command. So this docker build command will take that Docker file, execute each of the instructions, and at the end of it, we get this lovely, shiny Docker image, which should be capable of running our application. And so when you run through it, you'll see all of these instructions being made, you'll see all of the output being created, and at the end, we have this Docker image. This Docker image, just like we did with Windows Server Core to launch our command line application, can be run with Docker run. We say we want to run it in the background because it's a web service, so we want to run it in the background. We say run on port 80 because it's a web application, so we need to make port 80 available. By default, everything is sandboxed and everything is closed off. And so we need to be able to configure the right ports and the right network configuration in order to be able to access those processes. Again, it's kind of, we're having this secure by default mentality. And that's what we're going with. And so we have to explicitly say what port backmappings we need to make available to the public, which hopefully will mitigate if you're running MongoDB or Elasticsearch inside of a container. So I run this, I give it the name of the Docker image, which in this case I gave it the tag of nerddinner, and so that's what we're saying running. And then I really felt like I was back in the .NET world because it didn't run. This was because I had forgot to update my connection strings, and so it's like, okay. Or some other duplication is like, fine. So when I need to make changes to my application, what do I do? So we've now got our container built and container running, and so when we want to make changes to that, and when we want to release new versions, we would make the changes and rebuild the image. And this is where the ordering and the approach what we've taken in terms of how we structured our Docker file is important. So instead of it going through and reinstalling IIS and reinstalling .NET Framework and recreating the website, because of how Docker's been created, it's got some built-in caching, and it's got some built-in mechanisms that know if nothing's changed in the layers in the instructions above, don't just repurpose and reuse the existing image which came before it. Only create a new image when he's copied in files which have changed. Because if something's changed from the outside into the container, then the likelihood we need to run future commands. In this case, this is why we're seeing this using cache. So everything runs really quickly up until we do the copy, and then that kind of removes that previous container, and we get that new shiny image. This is now being fixed. It's now fixed a bug, which was due to connection strings problem, and we have our lovely shiny nerd dinner running inside of our container again. Now, this is running as a Windows container. Because, not that I don't trust John, but it is a 6-year-old application, may have some security problems, you never know. So if we wanted to add a little bit more security and run this as a HyperV container, we'd just assign the isolation mode. And so now when we start that container, what Docker will do is, when it's talking to the Windows kernel, instead of going like, we'll just start a normal Windows container, it will take the Windows Hyper-V virtual machine, that really lightweight, small thing. That has already been kind of booted up and frozen in memory in terms of some like really cool optimizations that the Hyper-V team do. And so then it will take that fork, it will unfreeze it, deploy our container onto there, and start it inside of that virtual machine. So we get that separate kernel, we get that added layer of security, and now we can run Nerd Dinner in a really highly secure, highly safe environment. And this all happens in milliseconds. Like there's 100 millisecond boot up time when you're adding isolation, but this is not like traditional booting a traditional virtual machine. It's very fast, very lightweight still, with very minimum overhead. The only thing that virtual machine is doing is providing a different Windows kernel, And if anything did break out, it's not writing it to disk. Everything's stored in memory. When the container gets closed and container gets stopped, that Windows VM, which is wrapping everything in, gets thrown away. Nothing is persisted to disk, again, to provide that more contained security layer. And so now we've got our application built, and we've fixed it, and we've got everything working, we've run through it a few times, and it's immutable. Like from now on, that image is what will get promoted from our development environment to, let's say, our continuous integration environment, to our staging server, to production. Any configuration tweaks which we need will define as environment variables or an outside influence. But the image itself doesn't change. And this makes it interesting when you talk about Windows updates. Because, traditionally when I start a Windows VM, Windows Update will happily keep myself secure and it will happily keep ourselves updated. So how does that work in a container operating way? Like if it's a frozen instance. And so Windows updates are disabled. Again, what we built should be frozen. We should be able to repeat that build and have exactly the same response. And so if we've got Windows updates running and deploying our own packages, that kind of breaks that mentality and that breaks that approach. So this is where it's important to know the Windows version number and how that relates to what you're building as your base image. So with our Nerd Dinner application, we used the latest, which was 14.393. And so on Microsoft website, they've got a hit history and a list of all of the different Windows version numbers, all of their secure IDs, everything which you need in order to know what your application was built upon and what version your application was using. When new versions are updated and you have the Patch Tuesday, traditional releases, you'll now have a new Windows Server Core base image. And it will have a new version number with a new tag. And so the idea being is that you would update your Docker file, you would increment that version number to be the latest, you'd rebuild your entire application, which would take into those new fixes, take into account those new security features, and then you would push that back through and redeploy that back through your pipeline. It's all about repeatability. It's all about that consistent way of building applications and making sure that what was built is exactly what's running in production and across servers without having these snowflake instances happening where everything is slightly different because things slightly change at different points in time as things were rolled out. And so that's how we get to that point with Windows containers. In terms of some operational important details, we've got our containers. We need to be able to persist some data sometimes. And if all we did was save data inside the container, when we upgraded it and when we deployed that new version, the data would have been in the container, which we stopped and removed. And so we'd lose all of that data too, which is very embarrassing. Trust me from experience, it's very embarrassing when that happens. So instead, you can mount volumes and you can mount drives from the host and make them available inside of the container. And these are fundamentally symlinks. What we're doing is creating a symlink from, let's say, C:\destination to in our container to C:\source inside of our host. And so that's how we can, anything wrote to the destination directory in the container actually ends up on our source directory. And so now if we redeployed and re-rolled out our container, we wouldn't lose any data. Particularly useful for things like log files. So we've got inet pub log files that can now end up on our host operating system, and so we can use those. Just like with Linux containers, we can add more security features if we need to, and more security defenses. So we can limit how many CPU shares and how much CPU processes, etc., we want the container to utilize. So now we can start delivering a quality of service across our deployment and to our customers or to our applications, because one container won't be able to take over the entire host. We can start ring-fencing it to make sure that everyone gets an equal share. We've got PowerShell API, so again, we can hook that into our existing build scripts and our existing pipeline if we wanted to start automating the container creation. And we can create new containers from PowerShell as well. So we don't have to use those Docker build, Docker run CLI commands. We can use the traditional PowerShell mentality which we wanted. So when I tried to deploy the nerd dinner first time, we had that traditional ASP.NET error message, and that was due to connection strings. And that was because we had a SQL Server dependency, which is pretty common. And SQL Server is kind of like one of those things most applications are going to need. So how does that look inside of a Docker world? So SQL Server is Dockerized. And we now have the beautiful case of having SQL Server for Windows containers and also SQL Server for Linux containers. With the recent port of the SQL Server for Linux, you can now run both versions as a container, depending on whether you want to talk Windows hosts or Linux hosts. Just in the same way that we did with our nerd dinner, we can launch this. We can say expose 1433, which is the SQL Server port. We can define a password. We can accept the end-user licensing agreement, and that will download and run everything. And if we wanted to see what was happening under the covers, because it's already in the background, we can do things like Docker Logs, nerd dinner, DB. And as I realized very quickly, SQL Server has got a little bit more security awareness than what I do, and so it doesn't let you just set the SA password a password, which kind of makes sense. And so by using the logs, I could kind of see and start debugging what was happening under the covers. And so everything which has been traditionally we're used to in terms of debugging had been thought about and collected in terms of the API. So we give it a bit more of a secure password. A password is long, yo. I think I was watching Breaking Bad at the background, or I had Breaking Bad in my head for some reason. Anyway, so now SQL Server started. We've got the SA credentials, and everything is happy. So this is how I got Nerd Dinner working. We had the front end. It could talk to SQL Server, and it could deploy everything. But we've got these two containers, and we've got these two dependencies, and keep running these really long commands. that needs to be documented, that needs to be stored somewhere, or I'm going to keep getting typos and forgetting what the password is. And so this is where Docker Compose comes in. Docker Compose allows you to take all of these arguments and define them as a YAML file. Again, using the amazing Chocolatey, we can install it from the command line. It would go down and it would download the executable, which we need. And to create the Docker Compose file, or to create the Docker Compose YAML, everything is defined, which we would traditionally have entered using the Docker run command. We just assign and we just take it and use the syntax to define our intentions. So we define our Docker image, what we're running, with a particular version number. We define our passwords. We define the ports which are required, and any dependencies which it needs. And then we can use Docker Compose up, which I entered at the bottom, Docker Compose up, and that will deploy both applications at the same time, and we'll have our running application running happily in our service. But then I saw this, and I thought, like, that's not quite how I remember it looking from back in the day. Like, that looks a bit weird, and also not very successful. So again, this was running IE. So again, I used Chocolatey, installed Firefox, and then it decided not to render the mobile version. And then it's just like the good old days, and nostalgia came flooding back for all the goodness. And so this was now an application. I now wanted to make it available and make it public. So it's running on Azure. Because when we launched it, we did that -p and exposed port 80. So now we just need to expose the Windows, the firewall in Azure, expose port 80, and then Nerd Dinner can rule the world using Windows containers again. I then got even a little bit more confident, as I'm running out of time, but I wanted to deploy the ASP.NET Music Store, which has been migrated to .NET Core. So I just wanted to see how that looked inside of a Windows container. So the third thing which is important is, because it's focusing on .NET Core, we no longer need to have like the full Windows Server Core installation. We can now start targeting the more lightweight, more cut-down version, because we don't need quite as much of the Windows functionality and the Windows API. And again, we've got the Docker file, which lists the instructions. It's a little bit more complex due to the file paths, but it's kind of still the same. We're adding some files. We're adding our NuGet package. We're running .NET Restore, which will go off and download it as part of our build package. We're adding the samples directory, which contains all of the source code. We're building that using .NET Build. And then at the bottom, we're defining how we start and how we run that application. And so this, even though it's a completely different application what we're building, you'll start to see these similar patterns and these similar approaches between what we're trying to achieve kind of come through. It's all about describing what your application is doing and the steps in order to be able to build up those layers to go from a blank installation of .NET to having your application up, built, and running. And again, we could use Docker Compose to list everything. Again, just doing Docker Compose up, and that's how we get to our running application running in the cloud. So now we've got this happy, but it's only running on one service. So how do we make that scale, and how do we scale that out? So the first thing we need to do is make the image available to elsewhere. So this is where you can push images to a private registry or private Docker registry, or the hosted Docker registry, which I did here. And your CI and CD build pipeline kind of looks something similar to this. Like a developer would do a Git push. This would go into something like GitLab or Team Foundation server, which would start the build. Your build agent no longer needs to have anything configured. Because all of the configuration is done inside of the Docker file, your build agent literally just needs to be able to run Docker build. And that's the only configuration it needs in order to be able to build and test what your application is doing. So that would happen. Once it's been successfully built, the output will be your Docker build image, which you can then push to like the private registry. And then you can use Docker pull or Docker compose up, which will grab the image and then deploy it onto your target service and deploy it onto your target machines, be it Windows Server 2016 or something cool like Azure Container Service, for example. But what about developers? Like, what if you don't want to run Windows Server Core as your development environment, which is a reasonable choice. Like Windows 10 is a really good operating system, so let's take advantage of it. And now Microsoft have announced and have officially supported Windows containers work on Windows 10. To install it, all we need to do is install the optional features, install containers, and then install Microsoft HyperV Containers, download the binary, and everything is happy. We then have Windows container support running on Windows 10. And so now we can build the images using exactly the same way, using the same Docker Compose, everything which we did before, we'll build it. And the reason this works is because it's taking advantage of that Windows HyperV container support. So everything runs as a HyperV container. So it's kind of having a guest kernel which has been designed for containers in the first place. And so that's why it doesn't interact with your Windows 10 deployment, and that's why it can work. And so now So now we've got Windows 10 container support. So we've got Docker for Windows, which is the tooling which you download, which is designed for running Docker on your development purposes. And when you download it, it generally downloads the Linux version with support for running Linux Docker containers. And so if you did Docker version, you'd have the server, you'd have an architecture, and you'd have like Docker images which are designed for Linux, Ubuntu, Nginx, .NET Core. In the command line, you can now say, once you've got Windows containers set up, switch to Windows containers. And then this will point the Docker client to point to your Windows Server installation instead, or your Windows Server support, Windows container support instead. And so now, when you do Docker version, we've got Windows architecture, we've got Windows images, and everything is happy. And we've got this really nice ecosystem and support on our development machines. And this doesn't affect anything. You can run these in side by side. It doesn't stop containers which are already running. And so now we can have these two great worlds happening where we can deploy and build our Linux containers and build and deploy our Windows containers from the same development machine, which I think is pretty impressive. Let me just... So what does this look like in terms of the future? And like, where do I think this is going? So Docker is everywhere. Docker is the hot, cool, new deployment technology everywhere. And so we've got Linux support, which has been around for the last 3 years, very mature and great functionality. We've now got Windows container support, and so we can take the same mindsets, the same approach, and start packaging up our Windows applications in an automated, repeatable way. We can also now deploy Docker containers onto ARM and IoT, so we can deploy them onto Raspberry Pi devices. But there's also a startup called Resin.io, which allows you to use the same mentality and deploy them onto really IoT-targeted devices. We've got SQL Server as a container, which runs both on Windows and Linux, which is super impressive. But what about Visual Studio as a container? Like, we've now got containers which work on Windows 10. And why do we now have to keep downloading 3 gig, 4 gig, 5 gig installation files of Visual Studio, which will then spend an hour, 2 hours installing to optimize itself and prepare itself? Why can't that just be run as a container? Why can't we just do a Docker pull Visual Studio and it download all the files which it requires and runs inside of a container, which is all isolated and sandboxed from each other? And so when we have different versions of our application running, one, let's say in Visual Studio 2000, to modify and maintain our lovely applications, and also keep up to date with our Visual Studio 2017, if there was a container, they wouldn't interact, they wouldn't interfere, and it would just happily work. And as new service packs were released, you would just download the layer instead of downloading and reinstalling the entire thing. We have this with Windows now, so why can't we start seeing it with Visual Studio and our development tools at the same time? And then we get to the point where everything is our container. Everything is running as a container. Our build tools, our build scripts, our build pipeline is all containerized. We're running Team Foundation Server as a container, and then that builds more containers, and then we push it onto Azure Container Service, and that scales out, and we can deploy it anywhere, be it in the cloud, be it on-premise or a hybrid of both. But this is a new world, and it's lots of moving parts, there's lots of moving pieces, and it can take a few attempts to become familiar with the pipeline. And so this is why we built Katacoda. This is why we've got lots of free content there to make it accessible, and make it as easy to start getting started as possible for you to start seeing the value of containers. And with that, I've got lovely red flashing lights, as well as someone shouting at me. So we've got 4 key points, apart from one I didn't have time to worry about. But we've got 4 key components. We've got Windows Server Core and Windows Nano. We've got the legacy way, which allows us to run any application, even if they're 6, 7 years old, and deploy it as a Windows container and have it automated and maintainable. We've got Windows Nano for our new cool applications that we can deploy and target a Windows server host operating system. We've got Windows Containers, which allows us to run them in still a secure, still an isolated environment. But with Windows Hyper-V, we get a little bit more. We don't have that shared kernel support, which we did before. We've got Windows Containers running on Windows 10, so we can use them as part of our development environment, test and build locally, and have that pushed up. And then host fingerprinting, which is all about building in cloud and having workloads distributed, and it's self-detecting whether it should be deploying Linux or it should be deploying Windows containers and which host to use on Azure Container Service. But that's for the next talk in the next NDC. That's around that time. In terms of my next, or what I'd recommend your next steps to be, if you want to know more, obviously Katacoda, because that's my baby. If you want to try this and play around, Windows Server on Azure is probably the best way to do it, because it's really quick to get started. Everything's been pre-configured, and everything, all of the images are there for you to jumpstart and get started very quickly. And then if you're more motivated, it works on Windows 10, so you can install the tooling, you can install the parts, and you can start playing around locally. And if you have any other questions, my details are there. I'm always available to provide more information. But thank you very much for your time, and I hope you enjoy the rest of your day.